Welcome back students for the 7th video lecturing. In this video I am going to discuss about torsion of cylinder and the expression for couple per unit twist for the cylindrical object. Later we shall discuss about torsion torsional of pendulum. So first I will begin with what is torsion of cylinder. Torsion of cylinder is nothing but twisting of cylinder that will be twisted by applying the torque. Torque is a kind of force which causes a cylinder to twist a certain angle. So it can be defined, torque can be defined as it is a measure of measure of the force that can cause an object to rotate about an axis. In order to understand the torsion of cylinder, I shall consider the cylinder whose one end is fixed, other end is free. In this particular figure, we can see that the cylinder one end is fixed, other end is free. So this type of cylinder, if the cylinder is subjected for the torque, what happens? The cylinder will be supposed to be twist in the same direction of force. The type of force which is required to twist a cylinder is nothing but rotational force or nothing but torque. See that the line, which is a line initially which is parallel to the top surface and bottom surface of the cylinder. The free end, it is the fixed end. Whenever if the cylinder is twisted by applying the torque, this is the direction of torque. Twisting is required to cylinder. The twisting, upon twisting, then the line is supposed to be twisted certain angle, that is phi because of the twisting. This twisting that will be taken place because of sharing of different molecular layers exist in the solid cylinder. This type of practical situation that can be arises whenever the cylinder is subjected for the twisting. This the order of twisting angle that can measures what will be the order of strength having the material which is used for various applications. If the phi is more, that type of material having the poor rigidity modulus, hence those materials having the low strength, they can be low strength that cannot be used for the engineering applications. If the material is having the low angular shift, that means low phi, that means here small angle, that means even some materials having the zero order of phi, that measures more strength of the materials. These cylindrical and this type of twisting that will be taken place in the automobile shaft in the automobiles. So next is what will be the expression for couple per unit twist. An expression for torsion of cylinder, that is couple per unit twist. Let us assume a cylinder, solid cylinder, and whose top plane is fixed, rigidly fixed, and the bottom plane is free, and they can be bottom plane can be subjected for the twisting by applying the torque. The length of the cylinder, is L. The from here top plane to bottom plane, the length is L. That means x to b is the length L, and the cylinder is having the radius capital R is the total radius of the cylinder, in which we shall consider a elemental area of this elemental or unit elemental layer. Here it is elemental layer. This is the elemental layer whose length is dr. Dr is the elemental layer of the cylinder, and the radius of elemental layer from here to here r. R will be the small r will be the radius of elemental layer. Capital R is the total radius of the cylinder. If the cylinder is subjected for the twisting by applying the torque on the bottom plane, if the cylinder is twisted in this direction, initially the line which is xb was parallel to all the planes, all the lines exist in this particular cylinder. See, this will be the O dash will be the axis of the cylinder, and the line XB, which is parallel to the O to O dash, and it is parallel to the outer surface of the cylinder. Upon twisting, the angle which supposed to be the B will shifted to the B dash. Because of that, the angle made by the shifted plane, it is called as phi. Phi is the shearing angle, that is BX B dash, the angle of shearing phi, and theta will be a angle of twist. What will be the angle of twist? That is theta. And what will be the shearing that will be taken place? That is phi. So the angle upon the twisting, an angle theta, the angle BO B dash, that is equals to theta, which is the angle of twisting. Later, the arc length B to B dash, the length of arc B to B dash length is arc length, one of the arc of the cylinder, whose length is equals to L into L means BX L into phi, and similarly from theta we can write the arc length as B to B dash is equals to r theta, that means radius, and the angle will be equal to r theta. It is the central angle. Then by using these two parameters, that is B dash is equals to L phi, B dash is equals to r theta, we can write it as L phi as r theta, r phi as r theta by L, which is called as equation number 1. Then the cross sectional area of the elemental region, that is dr, is equals to 2 pi r into dr. 2 pi r is the radius of the circle, area of the circle, dr is the elemental area. In the next slide we shall look up what will be the order of shearing force and shearing stress. If F is the shearing force, then T is the shearing stress. Shearing stress T is equals to force per unit area, F by area is 2 pi r into dr. So that means elemental area on which we are subjecting the stress. Then force is equals to T into 2 pi r into dr, which implies that the angle phi through which shearing takes place. Therefore rigidity modulus is the ratio of shearing stress to the shearing strain. So where eta is the symbol which is used for representing the rigidity modulus, and T is the shearing stress, and shearing strain is phi. Shearing stress phi means, so the angle through which that shearing takes place called as shearing strain, so that is phi. Then T is equals to N into Q. So if you simplify, T is equals to N into Q, that equal to N into phi, that equal to N, and we know that phi is equals to r theta by L. If you substitute r theta by L in place of phi, then eta r theta by L, which we shall consider this as equation number 3. Substituting equation 3 in equation 2, force is equals to in place of T, if you substitute nr theta by L into 2 pi r dr, this is equation number 2. So if you substitute this T in equation number 2, we will get force is equals to nr theta by L into 2 pi r dr. F is equals to 2 pi n theta r square by L into dr. If we simplify this equation, we will get 2 pi eta theta r square dr by L. Then the moment of force about an axis, that is O dash, is equals to force into perpendicular distance. This is the order of shearing force into perpendicular distance is small r. So force into perpendicular distance. Then the equation is equals to the moment of force along the axis, that is equal to 2 pi eta into eta into theta r cube by r cube dr divided by L. So this will be the force which is going to act on the layer. If the same, how many number of layers which are existing and what will be the total twisting force to each layer. So this is the order of force which can be expressed by one layer. There are n number of layers are there from r0 to r, from r0 to r. See that in this particular figure we have here r is equals to 0. This is from ear to ear, 0 to ear. There are n number of layers are there. Hence we supposed to be integrate from r is equals to 0 to r is equals to r. That means the total radius is equals to capital R, because each and every layers could experience the twisting force. Integration of 2 pi eta theta r cube dr by L. These are all the constant. I will take these are all the terms into the outside the integral. Then 2 pi eta theta divided by L, integration of r is equals to 0 to r is equals to capital R, that is r cube by r cube dr divided by L. The integration of r cube is r to the power of 4 by 4, integration from 0 to r. Then the total twisting force, nothing but a couple, that is C is equals to pi eta theta r to the power of 4 by 2L. Therefore couple per unit twist is given by C is equals to total twisting couple. That means total twisting couple is pi eta theta r to the power of 4 by 2L is the total twisting couple, by angle of twist. Angle of twist is theta. C is equals to pi eta theta r to the power of 4 by 2L is the twisting couple, and the angle of twist is theta. Couple per unit twist for the cylindrical object is C is equals to pi n, pi you can pronounce as eta, or you can call it as a n r to the power of 4 by 2L. If the rigidity modulus is more, then the couple per unit twist we required is more. If the rigidity modulus is less, couple per unit twist, that means twisting force is required is very less. So this will be the expression for couple per unit twist of a cylinder. Next in the next slide we shall look at what is torsional pendulum. Torsional pendulum is the kind of arrangement of the rigid body, so wherein which we suspend the rigid body by a wire by subjecting with a rigid support. See, this is the body, rigid body, which is suspended by a wire and with is having the rigid support. This type of arrangement is known as rigid body, and it executes oscillation in to and fro by torque, and which oscillation is always exist in an axis which is parallel to its center. This type of arrangement is known as torsional pendulum, whose period of oscillation is nothing but is equals to t. T is the period of oscillation, that is 2 pi under root I by C, where I is the moment of inertia of rigid body, C is the order of couple per unit twist which is given for the oscillation. So the torsional pendulum is nothing but an arrangement of the rigid body by a wire with a certain rigid support, and which executes to and fro oscillation by the torque, and whose oscillation is always about an axis which is passes through the center. And what will be the application of this torsional pendulum? So there are two applications. First application is we can identify the moment of inertia of irregular body. So If the regular body whose moment of inertia can be easily find out, but if the body is irregular whose moment of inertia cannot be predictable, because whose dimension whose area is it is impossible to find. Hence, in such case, we can use this particular type of arrangement. We can find the moment of inertia of rigid body. Upon that, we can find the rigidity modulus of the material wire. So this will be the material wire which is subjected for the torsional oscillations, whose rigidity modulus can be determined by forming this torsional pendulum arrangement. So this will be these are the two applications which generally torsional pendulums are used. Thank you very much. With this we completed the second module. So we will discuss some of the important numericals which are important for the examination in the next video. Thank you very much. I hope this video lecturing will help you people for the preparation for the external examination. So thank you very much.